We'll hope. Now, oh, wonderful. Okay, so the title is efficient use of electrical power, but in fact, what I'm going to be talking about is smart grid. Now, I want to make clear from the beginning that I don't know anything about the smart grid, but I have colleagues who work in the same division that I work, who know lots about the smart grid. So Jerry Fitzpatrick, Alan Goldstein, Tom Nelson, and Jerry Stenbakken are the leaders of that. Oh, wonderful! Are the leaders of that work, and they're the ones who have told me all about these things. So I'm hoping to transmit a little bit of what they've told me to you. There's the heroes of the work there. Okay, so here's the issue. We have this thing called the legacy electric power grid, and basically what it does is it makes electricity in big static generating plants. Those are AC plants by design. They transform the voltage up to very high voltage for long distance transmission, and then at the customer level they transform it down depending on what kind of a customer, whether it's a big or a medium or a residential size customer. So here's an even more simplified cartoon of this, and the key thing here is this is a one-way process, something that Steve emphasized when he was talking about the sort of legacy system. You make electricity in big static power plants and you deliver it to the customer. Now, the idea of the smart grid is to do lots of things. One is to have a much more diverse system where users may in fact be generating electricity. You might be generating electricity from solar cells on your home. Bigger installations like factories and apartment buildings and offices may be generating electricity for use locally, for example in microgrids, as Steve mentioned, and also sending it back into the grid. You have to have energy storage for all the reasons that we've heard about already, represented here by a cartoon of a battery, and as we heard, batteries are getting better all the time, so we hope this is going to work. I'm very much with Steve on the idea of pumping water. I grew up with farms where there were windmills that looked just like the picture that Steve showed, and it always seemed like a good idea to me. And of course, we've heard there's lots of other ways that you could store energy. You can use electricity to make fuels that you use later. So there's a lot of ways that you might store energy. That's not part of my story. The thing is, this smart grid is going to be much more of a web rather than a radial process, which is what the legacy grid mainly is. And one of the key differences is that now what we have is large, stable, centralized generation, a radial grid, and here's an important point. It's pretty static. You can predict the way this thing is going to behave. In the future, we're going to have, we hope, a high penetration of renewable sources, but a lot of those renewable sources are going to be variable. That is, if the wind blows, you get electrical power. If it doesn't, you don't. When the sun shines, you get electrical power, and when it doesn't, you don't. And that dynamic nature is going to make things a lot more complicated. The difficulties that you have with that kind of a system are akin to the difficulty of predicting the way in which some sort of a neural network might work, and so this is going to present challenges. Now, just as one illustration of the kind of challenges that might exist, here's what happened when a plant in Florida went offline sometime back a few years ago, and in a matter of seconds, the disturbance from that incident spread throughout the entire eastern part of the United States. So this is the sort of thing that has to be faced, that within seconds, you need to be able to respond to incidents, and as it turns out, incidents like this are going to happen more and more frequently. We've been seeing a linear increase in the kind of weather-related events that cause power outages, and this has caused all sorts of costs. The connection to sustainability is that a lot of people believe that this increase in weather-related events is because of climate change, and it's just going to get worse if we don't do something about it. And it becomes more and more of an issue the more complex the grid becomes, and the grid must become more complex in order to handle all the renewable resources. So one of the things that is absolutely necessary is, and this is where NIST comes in, my organization, we need information. We need a lot more than information. As Steve indicated, we need things like machine learning to figure out how to respond to the kinds of changes that this kind of a grid is going to have. But you're going to need information. You need to know the amplitude and phase of the electric current and voltage at a lot of different places, and you need to know it in real time. And here's where NIST comes in. We know how to measure electrical parameters, and we know how to timestamp them so that everybody who receives this information will know exactly what's happening simultaneously over the entire grid. Now, obviously, that's not enough, but it's one of the requirements that you have before you can do the kind of thing you need to with a smart grid. And so, just as an example, you can't read the legends on these graphs, but if you look on the graph on the left, this was what one of these sensors was doing in the way it was deviating from what it should have produced before NIST came in, calibrated the sensors, and allowed the manufacturers to adjust the controls on these sensors so that they measured the right thing. And on the right is how it performed after NIST told them what to do with these sensors. So here's a way in which the ability to measure things benefits the kind of sensors that are going to be needed more and more in this smart grid. So what we are hoping for in the future as a result of having a smart grid is that it will allow a high penetration of renewable resources into our electrical system, and also a high penetration of variable loads. For example, electric vehicles. If everyone has an electric vehicle and they all come home at 5:30 and plug them in, well, that's something that's a little different from the way things happen now. And we have to be able to deal with that. There's going to be microgrids, this idea that local communities will have their own grids. They'll produce electricity. They'll sell it back to the grid as a whole. They'll use it internally. That's going to create both opportunities and challenges. So all these things are going to be helped. It'll be more easy to integrate these kinds of things that are going to be beneficial to our general electrical power system if we have the kind of intelligence that is both measurement and response. And I've only talked about measurement in any detail, but obviously response is equally important. And so I just leave you with this thought that the instrumentation for the smart grid, which is what NIST is mainly involved with, is one of many developments that we need for a sustainable energy economy. Thank you very much.